Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying a lot. Like we are enjoying, we are learning a lot each and every day, guys. It's a new journey for us, and we are learning. So hope the same thing for you. So yeah, without wasting any time, let us jump into this session. Today is a coding session, which I love the most. So hope you guys have watched all the previous session videos. As I always say, please make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are talking. At least for this session, make sure that you watch the previous two sessions where we have taught you the maths, black box, and the theory concept of this gradient boosting. Hope you guys have that understanding, and this is a coding part. I hope like if you guys know about the black box, then it's gonna be very simple. Okay, so today is a coding part. Let's dive into this session. So before that, guys, if you are to this level, like I will really need to congratulate you because like this is a journey. I think it's like nearly 60 plus sessions we have done. So it's great. So now we have an understanding of how to handle the data completely. Okay. And we're gonna complete a, I will say, first quadrant of machine learning. So if we complete this means we are gonna complete the supervised learning concept. So I think the next thing will be like unsupervised learning, and then we're gonna see the algorithm, and we're gonna do in the same manner, guys. The thing is, we're gonna see the theory part, that is a black box behind it, and then we're gonna see the coding session. Okay. So yeah, guys. So if you guys do this, and if you guys doesn't subscribe to our channel, please subscribe to our channel because like every day we are posting a video, so you doesn't miss any of our video. So yeah, guys. So without wasting any time, let us jump into today's session. So today's session, we're gonna see the coding part of gradient boosting. Gonna be very simple. Okay. So first thing first, we're gonna import some necessary libraries. Now, if you guys have to this level, now you guys know what this entire thing. It's a collab. Okay. If you guys doesn't know, please make sure that you guys go back and watch the Python session where we have explained like entirely about this collab, what it is, how it is working, how to run it, where it is, what are the keys that we are having, what are the advantages we are having, everything we have done. Okay, so make sure you watch the video so that you can have a clear understanding of this IDE. Okay, next first thing, we're gonna import some necessary libraries in order to perform any kind of ML operation. So I'm gonna import some necessary libraries like NumPy as NP, pandas as PD. So NumPy is used to perform mathematical operation, whereas pandas is used to train the data set as a data frame, that is a table kind of thing. Next, sklearn.model selection, I'm gonna select train test bit, and then I'm gonna use standard scalar from preprocessing in order to perform some preprocessing kind of thing, and then gradient boosting classifier from Ensemble. I'm gonna import the gradient boosting classifier. As we mentioned, gradient boosting is the one of the Ensemble technique. Then from metrics, I'm gonna import the accuracy score. Dataset, I'm gonna use the inbuilt dataset, that is load breast cancer dataset, where it is a cancer dataset. We're gonna have the cancer radius, how much depth it is, how much thickness it is. Based on that, we're gonna predict a level of cancer, like whether it is a benign or malignant. Like that, we're gonna find. That is what about the dataset. Now, I'm gonna just load the dataset. So load breast cancer, and I'm loading it to the data, and then I'm just converting using the data frame in the form of a table. Then I'm just using a target in that dataset itself. I'm just creating a target column, assigning the data of target. That's it. So this is a dataset that you are having: mean radius of a cancer, mean texture of the cancer, mean perimeter, mean area, like that. It everything says the dimensions and features of the cancer and what is the target value, whether it is 0 or 1. It's a benign and malignant. I think malignant is very serious, whereas malignant is somewhat it is like an initial stage. So that, guys, this is what sir is always mentioning: we need to take a proactive decision based on this data science. And I am saying like it's a proven, and I will say valid decision based on the future data that we are having, or a data or a feature that we are having. Okay, future. So this is what, guys. So based on the features that we are having, we're gonna predict whether the person is having a malignant or benign, so that we can make the proactive decision. So this is what all about this data set. Then moving on, we're gonna summarize our data. Let's see what is the shape of the data. So it has nearly 569 records with 31 features, where one feature will be the target value, and the classes are 0 and 1. That is, in target we are having only two targets: one is malign and one is benign. And this is the first top five records. I think they have printed the head of it. Yeah, head means it's gonna print the top five. And then the column, target column unique means it's going to bring the unique values, that is zeros and ones. Df dot shape, shape of the data frame is like it has nearly 569 rows and then 31 columns. That's it. Okay. So hope till this everything clear. Now moving on, let's see whether we did some pre-processing for this data set. Df dot is null dot sum, which is used to throw us how many null values in each and every column. Guys, see here, there is no null values, then there is no problem. And also the data type is like it's an integer data type. So model can understand integer, right? So any machine learning model, they can understand the zeros and ones. Zeros and ones are wants to say anything. Numbers they can understand. So it is an integer format and there is no null value. So we can pass this to the model. So model can digest it. So now I'm going to segregate my data set into input and output. Except target column, it is my input. Only target column it's going to be my output. That's it. That is what I'm doing. The entire data frame, I'm just dropping the target. In the entire data frame, I'm using only target for Y. If I dropping the target, then it becomes X. That's it. Simple, right? Now this is what the entire X that we are having, except the target column. In Y, you guys see only target column. Okay. Hope you guys can understand, right? Now moving on. This is shape of it. So we have seen, right, the number of records is 569 and 30, which is our input, and that is only one for our output. Scaling, I'm going to use the standard scalar. I'm going to fit this scalar dot fit transform of x, and now you guys can see same column but like same number of shape, but like the model gonna have in a manner like it is like a standard thing, -1 to 1, like that it gonna have. Okay, so because like you guys see here, like we are having a point values and we are having 2-digit values here, we are having 3-digit values, so somehow here 4-digit value, so we need to standardize the thing, so we are using standard scalar. Then I'm going to split my data to train and split. So this is my input x scaled, which I have scaled the input data. Y is my output. Test size is 0.3, that means 30% of data for my testing, 75% for training. Random state, you guys know, right? Whenever whoever in this world run this code, they're gonna get the same accuracy. That is same kind of split. Okay. So x train, x test, y train, y test. Whereas for training, I'm having nearly 398 records, and for testing, I'm having 171 records. That's it. Okay. So for loading the model, I'm just loading a gradient boosting classifier. That's it. I'm just giving to the variable called as model. And then I'm just fitting using the training data, X train and Y train on my training data. I'm just fitting it. Fitting means I'm just training it. That's it. Okay, you guys know, right? Now, moving on, I need to predict it. So model.predict, I need to give my input, that is X test. Using that, I'm just predicting the Y pred. So this is the entire Y pred that we are having. Okay. Now I'm going to calculate my accuracy. Accuracy score. What is the Y test is the value which is present in the original data. Y pred is the value which is predicted by our model. How much equal it is? It is nearly 95%. Okay, it's good. Okay, that our model works this much. We have done a standard scalar and our model is doing very good. Okay, till this I think everything completed. We have imported necessary libraries, we have loaded our model, summarized our models, applied standard scalar, we have splitted our model like data set into input and output, then we have performed train and test on it onto it, and then we have trained it, we have tested it, and finally we have just gone for the calculating the accuracy. That's it. Finally, I'm going to predict a single sample, my x test of 0, that is like nearly 30 features we have seen, right? This is what the inputs that we going to see. So everything is like a range of minus values, like -1 to 1, I think so. That will be that thing, -0.1 something. Okay, but earlier it is like something different, right? 4-digit values, 3-digit value, 2-digit values are we are having, but like once we have standardized, we are getting this value. So whenever you give the input, right, you should standardize and give the input, then only the model can learn, sorry, understand and predict, because we have trained in a model manner that we have standardized our input and we have given. Guys, I hope like you guys have understand. Earlier our input is like this, like it can contain a point values, it can contain 2-digit value, 3-digit value, 4-digit value, but we have applied standard scalar, due to which here you can see, right, we have applied standard scalar. Okay, due to which now the model can becomes and learn only the scaled value, not the 2-digit, 3-digit, 4-digit value. Now we need to scale in a manner of -1 to 1 something, which a model is done. So Whenever you give the input, you need to give the standardized input, that is the 30 values. Those are our features, right? You guys see 30 features now. So if I give this to the model, this is my sample. So model dot predict dot sample, and it's gonna predict the output and gonna say whether it's a benign or malignant or bad. That's it. Okay, it is throwing a result as 1. That means 0 means benign, it's a malignant. So for this given 30 values, it is benign. So that's it, because like 1 is right, so 0 means it's malignant, 1 means benign, so we are getting 1, so that is, it is benign. That's it, guys. I hope there is nothing special which we have which we have learned for the past, I will say, 6 to 7 sessions. Okay, only thing that we have changed is just this thing, just the model name. But but you guys need to understand the flow. You need to import your libraries, load the dataset, summarize the dataset, then you need to split your dataset into input and output, apply the standardization, then you need to go for a train test split, then you need to load the model and train it, predict it, and then you need to find the accuracy like metrics, and then finally you go on to predict the single value. So this is the entire for, I think, 11 to 12 steps, I think so. Is it right? Yeah, 11 to 12 steps, nearly 12 steps you need to follow, so in order to follow all the machine learning model. Hope guys it's a simple understanding and you guys are like able to understand everything. If you guys stuck anywhere, if you guys need any input from us, please make sure that you ping you guys. We are here to help you. Just ping in the comment section, we will take up and we will solve your doubts. Okay, hope everything is clear. So this is a understanding on the way of teaching by me. So I hope it's like sir will have some more insight to give. Okay, yeah sir, over to you.
Yes, so let us start, guys. First of all, do reinforced learning. Go and watch all the sessions 5 to 10 times, absorb the information, digest the information, and apply the information and build long-term objective function for your career. And have persistency, consistency, patience, and become a lifelong learner. Okay, so and also subscribe to our channels, also press the bell icon so that you will get notification for all the sessions, and give us feedback so that we can improve all these sessions every time. So let us move to this. So gradient boosting, first of all you have to import all the necessary libraries. Okay, NumPy, pandas, sklearn, okay, train test split, pre-processing, okay, ensemble techniques. You have to use import gradient boosting classifier. You have to import sklearn dot metrics, accuracy score, sklearn dot data sets, load, and you have to load all these libraries. Then we go to step 2, which is loading the data set and creating a data frame. So for that, you have to load the data set and create a data frame. So we are loading the data, which is load breast cancer data set, which is there. So we are using that. And then we have to use data frame, okay, and the target variable. Okay, so once we do that, so we get the output. So that would be mean radius, mean texture, mean parameter, mean area, all these things you will see. Okay, and then we go to step 3. Yeah, target variable. And then we go to step 3, which is summarizing the data set. So print data set shape, df dot shape. Then you have to print classes, df target dot unique. Then print first 5 rows of the data, and which is df dot head. You can do with the tail also, and you get the summary. You get the overview of the data into 5 rows and 31 columns. Let's move to the 4th step, where we'll do pre-processing for the data. We'll check the missing values, we'll check all the anomalies, and then we are checking the missing values. So for that, we'll write print n missing values, print df dot in null bracket dot sum bracket. So we'll get the output as missing values. Okay, let's move to the other step, which is step 5th. Here we'll be segregating data set into input and which is x and output which is y variable. So x dot d x equal to df dot drop target x is 1 which is input feature and y equal to df target output target. So this is the output for the command x and y, you will see. Okay, then you have target variable here, and then we want to see the x shape and y shape, which is 569, 30, and 569. Okay, that is the shape. Then we go to step 6, performing the feature scaling. So here we'll scalar dot standard scalar. Okay, x scaled equal to scalar dot fit transform x. So this is the input, and then we'll have output x scale dot shape. So you'll see the shape 569, 30. Step 7, splitting the data into training and testing. Okay, data. So that we'll do with x train, x test, y train, y test. Okay, and then we'll have the output, which is 398, 30, 171, 30, 398, 171 as an output of xtrain.shape, xtest.shape, ytrain.shape, ytest.shape. Okay. And then we have step 8, loading the model, which is gradient boosting classifier, because this is the project for that. So you are learning those things. So according to the gradient boosting, so we need to load gradient boosting classifier, which is the model. Okay, as per the objective function of this project. So model equal to gradient boosting classifier. Then you have step 9, which is training the model. We have to train this model. Model dot fit x train y train. This is very important. You have to define this. Okay, because then and only it will train the model, guys. You have to define model dot fit x train y train. For all the models, you have to define x and y, because you have to train on something, right? Like teacher has to train student. Only in classroom, if you have teacher only, who is not going to teach the walls, right? Neither student only, he's not going to learn from the walls. So x and y is very important. Okay, so step 10, predicting the results using the train model. Then y predict equal to model dot predict x test. Okay, then you have y predict, so you got the output array. And then we have step 11, calculating the accuracy of the train model. Accuracy equal to accuracy score y test y predict, print f model accuracy into 100. Okay, and you will get the accuracy, which is 95.91, which is pretty good. Above 90 is a good accuracy for the model. It is really learned well. And yeah, so then we have step 12, which is predicting the output of the single sample using the train model, which is sample equal to x test 0 dot shape reshape 1 minus 1. So print sample input sample predict equal to model dot predict sample, and then you have print predict for the single sample 0. And then you have the, when you write this, you have to remember these terminologies, these functions, and these libraries, where to use, when, and what are the limitations. You need to know end to end. And then you get the output for the sample input, that is 0.47 and on dot dot dot. The prediction for the single sample 0 1, and this is the output. Yes, and I think this is it, right, Raja?
Yeah, yes, sir. Yes, sir. Yeah.
Great. So guys, mimic this project and do as it is. If you get error, write to us. We'll help you out. But apply this as it is. Mimic and imitate these steps. If even if you don't know, try to use Google Colab. Try to use different Anaconda or Python library or any tool which you are comfortable. But try to mimic this application so that it your every atom of your body will absorb and have a consciousness how you apply these concepts and how you use them and how you build models and how you experience all the steps. That's very important. Okay, at a feeling level, at a thinking level, at a higher conscious level, when you absorb these concepts, libraries, functions, concepts, when you apply them, you go to a meta level learning, guys. So go deep, understand these concepts, apply them, mimic them, and if you have any problem, any issues, write in the comment section. We'll be helping you. Okay, but mimic and imitate all this so that you will absorb, digest, and apply. So let's move to the other session. Thanks.
Yeah. Yeah, guys, like we have completed the coding part of gradient boosting. Hope the next session will be like more of like, I will say we have completed the supervised learning, and we're gonna see how to evaluate the model in the next session. Okay, how to evaluate this both the classification and regression model of this supervised learning. Then we will be moving on to the new part called as unsupervised learning. So today I hope like you guys have understand the coding part of gradient boosting. If you guys stuck anywhere or if you guys have any doubts, any clarification, please ping us in the comment section. We are here to help you. And one more thing, guys, if you guys doesn't subscribe to our channel, please subscribe to our channel and press the bell icon so that you doesn't miss any of our video. So guys, yeah, that's all about today's session. Hope you have enjoyed the session. We have enjoyed a lot, and we are learning and we are having a great time. So that's a single thing I can say. So yeah, guys, until next session, bye guys, take care. We will all meet in the next session. Bye guys.
All right, take care, guys. Do reinforce learning and subscribe to our channel. Also, press the bell icon and build long term objective function for your career and patience, persistence, consistency, perseverance. These skills, listening skills, communication skills, they are very crucial, guys. Once you have these skills, anything is possible in the world to learn. You need to have patience, you need to have perseverance, you need to have consistency, persistency, long term goal, patience, and communication skills deeply so that you can learn any skill in the world. Okay, that is the first architect design for learning any skill. There is no skill which you can't learn. Just build these faculties, consciousness, awareness in yourself. So there is nothing which you can't achieve. Keep learning deeply. Thanks a lot. See you in the other session.
Bye guys.